Okay. So far we have been talking about transformations. We have discussed three types. Whenever we were adding or subtracting either in the function or with x, it was translation. When minus sign was used, that was reflection. And when we were multiplying a number, let's say 2, 3, 4, 5, that was basically stretch. For x and y, things were different. Let's look at this example and then things would get better. Okay. All right. Now this is the question. The diagram shows the graph of y equals f of x. Sketch the graph of y equals 2 f of x minus 3. Now this is something that Munja was talking about yesterday as well. Okay. We have two things here. 2 is being multiplied with the function, and then we have this minus 3. So this minus 3 means what? Can anyone tell me? Yes. Which transformation is it? Is it reflection?
I think the translation, the minus 2.
It's translation.
Very good. It's translation. Whenever we are adding and subtracting to the function or x, it is translation. Okay. So this is translation. And translation was nothing but just shifting the graph according to whatever we had. And when we are multiplying this number with the function, this was basically stretch. Okay. Okay. So yes, that's true. Some times things are different for x, but here both the cases are being done for the function. We are multiplying 2 with the function and we are subtracting 3 from the function. So first of all, using BODMAS, I am going to look at the effect of this 2f of x, what effect this would make on my graph. Okay, now forget about this graph. Like this is a graph, forget about the function actually. This is just a random graph. And first of all, if I say this is the graph of f of x, what would be the graph of 2f of x? Now, I told you guys yesterday as well, for whenever the stretch is along y-axis, you need to make sure that your x-intercept remains the same. Okay, so this is between 0 and 1 and this is between 1 and 2. Be very sure that these 2 points remain same. These 2 points remain same. Imagine that on these 2 points something is fixed on this graph, and then when you will pull the graph, your graph would actually stretch. Okay, and other than these 2 points, every point would be multiplied by 2, like every y coordinate would be multiplied by 2, and your graph would actually become a shifted version of how it actually was. For example, if I look at this point, it is 1 over here, but when I will multiply it by 2, this would become 2. Similarly, this point, this point, this point, and all these points, all of them are basically against y equals 2. Okay, do not worry, things would make sense in some time. Just relax. Then this was my original function. This point is 3. So this was 3. This was 3. When I will do 2 multiplied by f of x, this would become 6. And this is how it is. This is how it shows on the graph as well. Okay. And if I talk about this point, this is basically minus 1. So minus 1 multiplied by 2 would give me minus 2. So we know since 2 was being multiplied with the function, whenever a number is being multiplied with x or function, that is stretch. And if it's being multiplied with the function, the stretch would be vertical. And if it is a vertical stretch, nothing is going to happen to the x coordinates. Okay, the x coordinates, the x-intercepts are going to remain same. For instance, at this point, since y was 0, so when we will multiply the 0 with 2, this would again remain 0, right? So that is why this point is here. Nothing is happening to this point, but every other point is being multiplied by 2. Every y coordinate is multiplied by 2, and then we have modified version of our graph. Okay, so it looks like a genuine stretch along the y-axis. Okay, it looks like somebody just pull the graph both up and down, and the x-intercepts were fixed, but other than that everything has been changed. Any confusions so far? So far we have just discussed the stretch.
No, Miss, everything.
Okay, all right. And a good practice is, now some of you could have stretched, some of you could have said, why didn't we translate first? Why are we stretching first? Because it's fine, you can do it other way around as well. For some examples that thing would also work, okay, and for this one as well. But it's good that you do this according to BODMAS. We use multiplication first, we do multiplication first. That's why we are doing multiplication first, and then we'll translate. Okay, now we have this thing. Now we have 2f of x. We have the graph of 2f of x. Here's the graph of 2f of x. Now when you will do -3, what would happen? Firstly, this -3 is done with the function. This means that the graph would basically translate, and the translation vector is going to be, what would be the translation vector? Can anyone tell me? This is the x coordinate, this is the y coordinate, and for translation, things used to be opposite for x. Nothing is happening with x. We are just subtracting with the function. So x would remain 0, and y, I've been telling you for y, things are the way they are. So I would just write down -3, and this is going to be the translation vector for this one. Okay. Anyways, I'll come back to these important things later on. I did not even discuss this for stretch as well. For now, we're just looking at, an easy method to make the graph. Okay. So 2f of x is done. Now -3. Okay, where's -3? Okay, all right. I did not add that part over here. I will directly just remake it. But certainly we'll have to do something about -3 as well. Okay. Yes, that's true. Okay. Now this is basically my graph. Okay, I'll make the graph on the same paper. What is -3 going to do? -3 is basically going to shift the entire thing 3 units down, and this is very easy. So what are we going to do? This point is -2, where I will shift this entire thing 3 units down. So this point would come over here at -6. And this point, that is, for now it's at 2, this would come at -1 right here. So it would be this one. Okay. And then this point right here is at 6, this would come at 3. So this line would basically be made at this point. Let me make it again. Okay, all right. So for stretch, we just stretch the graph vertically, and after that we add -3, and for that -3 I am just going to shift the graph 3 units down. Okay, so for that, just pick up some random points of the graph. For example, I'm looking at this line and I'm going to shift it 3 units down, and then this line I'm going to shift it 3 units down, and then this point. So let me just connect this entire thing properly. Not this. Something of this type. Okay. All right. Now what have we done so far? Okay, let me give a quick recap so things are easy, and then you guys can ask questions. Okay. We have discussed translation, stretch, and reflection separately. Here we have combined transformations where we will be dealing with 2 or 3 transformations at a time. Okay. It was 2f of x means it is stretch, minus 3 means it is translation. Both the things are done with the function. So the stretch would be along y-axis and the translation would basically just make your graph move 3 units down. So when I say up or down, it basically means the translation is also done along the y-axis. Okay. For the stretch, we know whenever it is along the y-axis, x-intercepts are going to remain same. Or do not remember this. Just know every point would be multiplied by 2. That is it. Okay. So this entire line that was at 1 initially would now move to 2. Now it's over here. Then this entire line that was at 3 initially would move to 6. Now it's over here. And this point was at -1. It would move to -2 right here. Okay. And then we just made a line. That is it. And this was stretch. But to answer and to talk about stretch, how do we write down things? So here it is. It was a vertical stretch and the stretch factor was 2. Either you can write down vertical or horizontal, or you can write down it was along x-axis or y-axis, right? So for stretch, 3 marks. First of all, you'd have to talk about the name of the transformation, that is stretch, then the stretch factor, and then if it is along the x-axis or the y-axis, vertical or horizontal. So 3 important points for stretch. Okay. Once we were done with stretch, then we need to translate. For that, it was -3. You need to pick up the entire thing and take it 3 units down. That is it. Okay. So what happened now in stretch? You guys can also say in stretch we multiplied every point with 2, but actually we the graph stretched. Yes, because we just took 3 points, this one and the third one right here for reference. We just remade those points and then made the entire graph, so it looked like a genuine stretch. For translation, we are going to pick this graph and take it 3 units down. So this went 3 units down, this went 3 units down, and this thing, so it would be -5. Yes, it would be -5. From -2, this would go to this point right here. So it would be this, and it would be this one. Okay. This would basically be the graph. Okay. After doing the translation as well. And for translation, we have the transformation name, that is translation, and then we have the translation vector. So we only have 2 things for translation vector, and this is how we write down the translation vector. So it's for the x coordinate and it's for the y coordinate, and yeah, that is it. Anything that's coming to your mind, please ask me now. Munja, Ahmed, Mutasam, and Rafe.
No, miss, everything's clear.
Okay, and what about the other students? Yes, Munja?
How did on the second graph down there, it goes to 4. I didn't understand that. I didn't understand that part. Is it an arrow, or I mean, how did we get -4? -4 and the coordinates are -4 and 2.
No, -4 and 2.
Yeah, on the second graph.
1 second. This one?
Yes, yeah, that's
okay.
true.
Okay, I'll tell you. So the 1 second, the blue graph, let me just erase. Translation is easy for you guys. Okay, we know translation.
Yeah.
That's fine. Okay, this was basically the stretch. 2 was being multiplied with the function. So for the first part of the question, I just considered this 2f of x, and I have just discussed stretch. 2f of x means every y coordinate would be multiplied by 2. For example, if you look at this y coordinate, this initially was 1. Okay, this was 1. The y coordinate is 1. I will multiply this 1 with 2, and this would become 2. Nothing is happening to the x coordinates. They are going to remain same because we did not do anything with the x-axis. Okay, then if we pick up any other point, let's say this one, this was at 3. So I will do 3 multiplied by 2 because this is f of x and this is 2f of x. Every point is multiplied by 2, and this would become 6. Then this one was -1, and then this would become -2. Every point was multiplied by 2, and our graph would actually stretch along the y-axis, right? Not every point, every y coordinate of every point, not the x coordinate, okay? Only the y coordinate, because we multiply this 2 with the function. Yes.
Okay, thank you, ma'am.
Okay. Okay. Mutasam and Ahmed, anything that you would like to ask? Yes, Ahmed, any questions? I'm not able to hear you. Okay, you guys can just type, okay? And Mutasam, what about you? Anything that you would like to ask? Okay. All right, perfect. Okay. So let me just talk about another example, and then we'll talk about past paper questions. Okay. Now it says, the diagram shows the graph of y equals x squared and its image y equals g of x after a combination of transformations. Okay. All right. Find two different ways of describing the combination of transformations. So take your time. Even I don't know at this point what would be the answer. Okay. We know that we have three things: translation, reflection, and stretch. Okay. It doesn't look like reflection, certainly neither along x-axis or y-axis. This is not the case. It could be translation and it could be stretch, because the blue graph is, it's very, very broad, and the red one is shrinked version of how it was for the blue one. And uh, this point has also changed, right? In stretch, the x in stretch, whenever the stretch is along x-axis, the y-intercept has to be same. And whenever the stretch is along y-axis, the x-intercept has to be same. But this point is also shifted from that to over here, means that things are a little bit different over here. Okay. All right. Okay. So yes, it certainly looks like they have used translation and they have used stretch here. Okay, let's think about it. Okay, now find two different ways of describing the combination of transformation. So this basically means that you can use two different things and you would be able to get the red graph. Okay, now I would want you guys to think about it and then just comment down in the chat box, so I'll see and I'll know if you guys were able to understand the idea or not. It is certainly translation and stretch. Nothing else has happened over here. It is translation and it is stretch. But what translation vector and what stretch factor? Yes, that is my question. Please think about it. Okay, I got one answer and I want all of you to participate in this. Please think about it. I would not mind a wrong answer. Okay, all right. Very good, Rafi. Your answer is correct. Okay, let's talk about this. Okay, now let's talk about one scenario. How things could have been over here. Okay, I certainly know that since the blue has shifted to red, so it has translation. And other than this, the red graph is shrink, so it has stretch. For translation, we just have the translation vector, and for stretch, we have two things: the stretch factor and along what. Okay, the current scenario that we have discussed, let's talk about that. So it looks like since we have moved from 0 to 2, the graph has shifted towards the right side. So it looks like the translation was basically done along x-axis. Okay, that part should be clear. Okay, and if I talk about the translation vector, so it's x and y. For y it is 0 because nothing has shifted along y-axis, and it would be 2 for x. Okay, it would be 2 for x. And for stretch factor, it's very simple. This length is 4 units. So initially my parabola was 4 units broad, and then this length, this one, this is 2, sorry, not this one. This one right here, this is just 2 units. Okay, so what do you understand by this? This was 4 units. This is 2 units. It means that the stretch factor was yes.
0.5.
Okay, and what about the other students? Can anyone guess this one? It would be 1 by 2.
I guess
Yes.
minus. I guess it's -2.
What, the translation?
No, the stretch.
No, the stretch is 1 by 2. Why is it 1 by 2? Because you can see from 4 we have shifted to 2. Okay, when it is about translation and stretch, when we are talking about these things, the translation vector or stretch factor, that is what it actually is. You will get to see some weird things once we talk about the equation. Okay, so for now, just forget this part. That's not important. That would just confuse you. And just know that the question was find a way of describing the combination of transformations. Okay, so from the blue graph, we got the red graph by translating it to 2 units and by stretching it by stretch factor of 1 by 2, because our graph is actually shrink. It did not stretch horizontally, it shrinked. Okay, it was initially 4 units and now it is 2 units. That certainly means it has shrinked. So stretch, and the stretch factor is 1 by 2 along x axis. Let me show you the formal way of writing it down as well. So this one is not needed. Forget about it. It's just some of you would be able to understand it, but most of you would get confused. This is just another way of writing it down. This is what we have discussed. Okay, so for stretch, they're writing down its horizontal stretch or stretch along x-axis, and the stretch factor is 1 by 2 followed by translation, and this was your translation vector. There's no hard and fast rule of writing it down this way, but yes, this has 1 mark, this has another mark, and this has the 3rd mark. Or let's say if this entire question was for 2 marks, then you need to answer all the important things for stretch, and then you would get that mark. And for translation, it's just the name and it is the translation vector. Okay, any confusions with this, how we went from blue to red? Anyone who would like to ask something, please ask me.
No, miss.
Munja, Motasam and Ahmed, please tell me if you guys were able to understand this or not. Okay. All right. Now, the next part is we need to write down the equation of g of x. This is g of x. This is the equation of the original one. We know that we incorporated stretch and translation, and then we got the red graph. Okay. So it is y equals x squared. Translation was of 4,0. So we are going to subtract 4 from x. You guys should know by now things are other way around when it is about x, okay? The rule was that if it was a and 0, this meant it would be f of x minus a. So same has happened. It is x minus 4, okay? And then stretch factor of 1 by 2 basically meant what? Stretch factor used to be 1 by a. This means that a is 2 and it used to be f of ax. Okay, so we are going to just multiply this with x. So a is 2. I'll multiply 2 with x, and this is what I am going to get. Okay, in short, things are opposite for x. If you guys are not able to understand this, it's just because you need to revise and you need to see how things are for x. Once you're done with all those key points I shared, I'll share the notes again. You would get a better understanding of the idea. Okay, so this was basically the rule that if this is your translation vector, this would be the change on the function. And if a was equal to 2, a was basically this number. The stretch factor used to be 1 by a, that is 1 by 2. But actually, we won't be multiplying 1 by 2 with x. We would be multiplying a by x, and a was basically 2, right? So this is going to be the equation for g of x. Yes. Is it okay?
Miss, like the translation vector is 2 and 0. So why are we writing -4 instead of -2?
No, wait 1 second. Yes. I'll tell you why. Because for the, when I crossed out something, this was basically another way of writing the same thing. That is why they have just explained this to that. Okay. If we talk about our scenario, it would be 2, 0 and 1 by 2. We can write down 2 here. That's perfectly fine. And then we would have a 2 here, and then here, and then here, and then here. Okay.
Okay, miss.
Yes. Okay. All right. Now, those who were not able to understand anything, it's completely fine. Please now try understanding things and it would get better. Okay. We still have 10 minutes. Let's talk about this question. It's important and you won't get to find too many questions from this chapter. So I was only able to find two, questions from 5 years exams. Anyways, let's get started. Okay. In the diagram, the graph of y equals f of x is shown with solid lines. Okay. The graph shown with broken lines is a transformation of y equals f of x. Okay. So this solid line graph has been transformed to this dotted line graph. Describe fully the two single transformations y equals f of x that have been combined to the resulting transformation. Okay. We did something with y equals f of x, and then we got that dotted line. Okay. All right. So let's try thinking about all the three transformations that we know and then think about it. Okay. Now it genuinely looks like it is obviously not reflection. So we have translation, we have reflection, we have stretch. It's not reflection because everything is in one quadrant. And yes, it looks like stretch because the image has enlarged. And yes, other than enlargement, it has shifted as well. So it has translation as well. Okay. This is going to be the idea. Okay, all right. And another thing that we need to understand is what are the measures of these transformations. For instance, if it is stretch, what is the stretch factor? And if it's along the x-axis or y-axis, and since it's translation, so what is the translation vector? Okay, let's talk about stretch first. Okay, I can talk about any side. Let's say if I talk about this side, it's obviously not going to be very accurate, but the idea should be clear. It's basically starting from 6 and it's ending at 3. So we can think about it as if it is on 3 units. And if I talk about this part, it's only on 1 unit. Okay, so it has stretched vertically, and it was 1 unit initially, and now it is 3 units. So the stretch factor is how it looks like. The stretch factor would be 3. And is it vertical stretch or horizontal stretch? It's certainly a vertical stretch. So you can write it down this way. Let me answer it for stretch. Stretch by a stretch factor of 3 along y-axis. This entire thing would give you 2 marks. Okay, this entire thing would give you 2 marks, and all of this is important. First of all, the transformation name, it's stretch, then the stretch factor, that was 3, and then if it is vertical or horizontal, so we've written along y-axis. Okay, all right, this has just stretched this thing, and then we have shifted it. Okay, then it has been translated. So if I talk about translation, let me just stretch this for now, just so I get to understand one concept. Okay, I would not be able to stretch it over here because the axis is very small, but I can just try doing it. Okay, all right. It's going to be something of this type. Okay, and then this thing has been, or obviously not this type, this would also extend like that as well. So it's good that we consider this one. Okay, this exact thing would be made over here, and it would basically be stretched vertically. Okay, then that thing that you would get would be shifted. Can anyone tell me the translation vector? What do you guys think about the translation vector? Any idea about the translation vector? Yes, if it would be 3 units, this 2 would basically go to 3, 6.
Miss 4 and 2.
1 second. Yes, that is that. 4 is correct, but 2 is not correct. I'll tell you why. Because, you know, for that, we need to make a rough sketch of that. Anyways, let's just try making it. Okay. First of all, since it is a stretch by 3 units, let's see how this graph would stretch. Okay, I know I need to multiply every coordinate by 2. So this point would basically go to this point, and this would basically go to, it was 2, so it would become 2 over here, and this was 1, so this would be multiplied by 3, and it would basically move to this point. After stretching it vertically, this is going to be the situation. Whatever I made initially was just to explain how stretch is. But if I actually use all the, information and everything, this is going to be the case. Okay, I'll tell you why. Please listen to me carefully. The black solid graph has been stretched 3 units, and that is clear by looking at one side of the both the graphs. Okay, this is 1 unit and this is 3 units. So it clearly means that the stretch factor was 3. How exactly the stretched version would look like? This is the solid line. This point is 2. When I will multiply this point by 3, this would become 6. This point is again 2. When I multiply by 3, it would become 6. And this point is 1. When I will multiply it by 3, it would become 1. So this is how my graph would look like after stretch. Now tell me the translation vector. Now you're not supposed, for translation, you're not supposed to look at this one and this one. No, that would not give you the correct answer. For translation, we are going from this point to this point, then things should make sense. Otherwise, we did not use stretch factor. Like stretch would make a difference, and after that difference, you need to think about translation. Is it making sense, Rafe?
Yes, miss.
Munja, Ahmed, and Motasim, please tell me if you guys are able to understand this or not. Okay, all right. Okay, Ahmed is, and Munja and Motasim, please tell me honestly. I would agree this is a bit complicated, but it would get better with in some time. Okay, so this has shifted to 1, 2, 3, 4 units. Okay, so translation, nothing happened to the graph vertically other than stretch. Once I got this blue graph, I did not move it vertically. So for vertical, it would be 0. And for horizontal, it is going to be 4. So the other one is translation. And for translation, we just have the translation vector. And the translation vector is, you obviously will be writing down the entire thing. I'm just writing down these words just so we understand the idea. Okay, this would basically be the graph. Okay, so I'll just explain this one last time and then that is it. We had this black solid line graph and this shifted to this dotted line graph, and this is what students do every time. Okay, so initially one thing was clear, reflection was not there, but translation was certainly the case and stretched was certainly the case. Okay, after stretching we could see, and 1 second, you guys could have said that why has this black graph shifted to the blue graph? Like why did not the basic points remain same? So I have been telling you guys already, for stretch, whenever the stretch is along y-axis, the x-intercepts are fixed, and we do not have any x-intercept for the black graph, right? We do not have any x-intercept for this graph. So everything would basically shift to another side, and that is going to be my graph. Okay, anyways, now for translation, you need to compare the blue graph and the dotted line graph, and you can see the translation is only along the x-axis, it's not along the y-axis. Okay, any confusions with this?
No, miss.
Mutsam, Munja and Rafe, please ask me.
Yeah, no, ma'am, thank you.
Okay, all right. So I hope that you guys were able to understand this thing. And yes, so I'll stop the recording.